Okay, let's start the class. So, yes, good afternoon, guys. Welcome back. Yes. So, a very good afternoon, guys. Welcome back to NEET World Institute and NEET World YouTube channel. Right. So, yes, we are discussing the topic called gravitation, and you know that this particular series is for the EAPCET aspirant, that is, who are going to write the exams in 2026, right, the upcoming year. And this is for both the medical as well as engineering stream students for physics subject, right. So, let us start with the topic. Yes. So, let us wait for 1 minute, like the people are joining over here, and once the PPT loaded, no, we will start with the class, right. Okay. So, let us start the class. I guess the screen is visible, right? Fine. So, in last class we were discussing the topic, that is gravitation field strength, right. So, this is the topic we were discussing, and what was the formula we were seeing for this. So, when we talk about the force, gravitational force, which is nothing but F is equals to G m1 m2 by r square. So, when we talk about in field, no, it is G m by r square by m. So, the final formula will be Gm by r square. This is my gravitational field strength formula, right. So, up to this we were discussing, right. No. So, when we are talking about the relation between the weight and the acceleration due to gravity, right, acceleration due to gravity. So, when we talking about the weight, no, what is the meaning of weight? Like it is mass into gravity, it is always acting towards the center of the earth, right. It is like when we talk about in the diagrammatic way, it will be towards down, right. So, electric field, like gravitational field will be W by m, which is nothing but mg by m. So, mm will get cancelled, it is g. So, it is gravity, right. No. So, this is my field strength. So, the value is 9.8 meter per second square. So, for problems we will use approximately 10 meter per second square as the value of g. Okay. So, this means the gravitational field strength near the earth is the same as the acceleration due to gravity. So, that is 9.8 meter per second square. Okay. So, the next one is how we are calculating the gravitational field for the point masses, point masses. So, when we are talking about a point mass, no, suppose this is my system, okay, this is my system where I can experience a field while I am keeping some mass over there, right? No, how I am experiencing, like because of the mass presence and due to the force, so I am experiencing that the field is there. So, obviously the formula will be Gm by r square, right. So, when r increases, field strength will be decreases. It is inversely proportional. E is inversely proportional to r square, right. So, gravitational field around the point mass decreases as 1 by r square, 1 by r square, because it is inversely proportional. When r increases, sorry, decreases, E increases. When r increases, E decreases. So, this is the concept, right. So, can we go for the next one? So, the next one is gravitational field due to circular ring, okay. So, the formula for this is E is equals to Gm r by r square plus r square. What is this r square? This capital R is the radius of the circle, okay, radius of the circle. So, we will try to know only the formulas, like E is equals to Gm by r, Gm r by r square plus r square power 3 by 2, okay. So, when we talk about the condition, no, conditions. So, first condition, so r is like small r is greater than capital R, like the distance between the masses, okay, it is larger when I compare with the circle radius. So, we can neglect that, like r is approximately equals to 0. When is r is approximately equals to 0, what will happen? E will be equals to G m r by r square power 3 by 2. When r, I mean 2 and 2 will get cancelled off, the remaining will be Gm r by r cube. So, 1 r and 1 r will get cancelled. So, final answer is Gm by r square, Gm by r square, right. So, when it is near, no, the points is near. So, capital R will be greater than the small r, right. No, what happens in this case? Small r is approximately equals to 0. So, again what we can assume here, E will be equals to Gm r by r square power 3 by 2. So, this 2 and 2 will get cancelled off, the value will be Gm small r by capital R cube, right. So, this is the two conditions when we talk about circular ring. So, circular ring formula is, it is Gm r by r square plus r square power 3 by 2. When capital R is less than small r, the formula is Gm by r square, small r square. When capital R is greater than the small r, so formula is Gm r by r cube, okay. You can take a note of this. Done. Can we go for the next one? Okay. So, the next one is gravitational field due to uniform disk. So, the formula, it is E is equals to 2 Gm by r square into 1 minus cos theta, okay. So, the previous formula was E is equals to Gm r by r square plus r square power 3 by 2. This is for circular ring. For point mass, the formula is G is equals to Gm by r square, Okay. So, two formulas we have learned in the previous slides, and the third formula is due to uniform disk. Uniform disk formula is simple, 2 gm by r square, right, into 1 minus cos theta, 1 minus cos theta. So, this is the formula. Okay. So, the next one, gravitational field due to uniform solid sphere. Disk completed, now it is a solid sphere. So, totally two cases. Case 1 is external point, external point. External point in the sense like capital R will be less than the small r. Okay, capital R will be less than the small r. So, whatever formula we have got for the circular ring, the same. Okay, E is equals to gm by r square, E is equals to gm r by r cube. Okay, when capital R is greater than small r, capital R is less than small r. These two formulas for the solid sphere. When we talk about the circular ring, the same formula takes place there, right. So, gravitational field due to thin spherical shell, So, inside the shell it is 0, yes, and outside the shell it is gm by r square. Okay. Inside the shell in the sense like when I talk about this is my shell, when I take inside the shell it is 0. When I talk about outside the shell, no, like the distance between will be 0. Outside the shell in the sense the distance will be there, like from this point to, from the center to this point will be, there is a distance, that is r. Okay. So, two cases, outside the shell it is gm by r square, inside the shell it is E is equals to 0. Okay. So, the next one is acceleration due to gravity. So, I need to know what is the acceleration due to gravity and how we got that acceleration, that is 9.8 meter per second square, how we got. Okay. Now, we will take a note of that. So, the force of a gravity acting on a unit mass of a body lying on or near the surface. So, we are considering the mass which is m on the surface of the earth. So, what is the like earth's mass? It is capital M. Like the point mass which we have considered is small m. Okay. So, the formula will be, we know the formula, F is equals to G m by r square, like capital R I will take. Okay. Like r is the radius of the circle, capital M is the mass of the earth, and m is small m is the point mass which we have considered. So, one force we got, equation 1. And other force, no, like we know from the Newton's second law, right, F force is equals to mass into acceleration. What acceleration we are talking? It is gravity, right. So, it is mg. So, this is my second equation. So, when I equate the first and second, no, what will happen here? G capital M small m by r square will be equals to m into g. Small m and small m will get cancelled off. We know the values of gravitational constant, mass of the earth and radius of the earth. So, finally we will get G is equals to gm by r square. So, G is nothing but 6.67 into 10 power minus 11 and mass of the earth is 5.96 into 10 power 24 approximately, and radius of the earth is, it is 6.38 into 10 power 6. So, when I calculate, we will get it is 9.8 meter per second square as the gravity of the earth. Okay. It is the acceleration due to gravity of the earth, that is the value. This is how we will get the equation. Okay. You can take a note of this. Done? Okay, can we go for the next one? Okay. So the next one is acceleration due to gravity above the surface of the earth. So when we talk about yes, I will take the previous diagram only. When we talk about the point mass which is on the surface, okay, we got the gravity as 9.8 meter per second square, right. When I take this point mass above the surface of the earth and below the surface of the earth, what will be the gravity? Will it be changed or will it be same? That I need to calculate it, okay. So based on this the questions will be there. So acceleration due to gravity above the surface, as we know that g is nothing but gm by r square, Now we know that its radius of the earth is r, we have considered as r. When I take to height h, no, it is r plus h the whole square I need to take. So r plus h the whole square, right. So similarly it is f by m, right. So when we substitute, like when we take this as equation 1 and this as equation 2, right. So from this we will get gh, like gravity at height h will be equals to g into 1 minus 2h by r. So where h is the height which we have considered from the surface of the earth and r is the radius of the earth, right, and g is nothing but it is 9.8 meter per second square. So g decreases with height. When we talk about this value, obviously g decreases with height. When I take to the height h, no, obviously it gets decreases, okay. Okay, done. So we will go for the next one. So acceleration due to gravity below the surface of the earth, in the sense r minus d I need to take, like depth, okay, depth. So the final formula when we talk about for this is g, like gravity due to depth will be equals to g into 1 minus d by r. So here also gravity decreases when we go down, okay, right. So for the height also it decreases, for depth also it decreases, okay. So this is the thing we can understand from this three topic: gravity 9.8 meter per second square, and when it goes height it will decreases, and when we go depth it will get decreases, okay. Now, so non-sphericity of earth, we usually assume earth to be perfect sphere, but actually it is not. Why? Because the earth is slightly flattened at pole and bulged at equator. Why we are talking about this topic? So when we talk about this topic, no, we come to will come to know that at equator what is the gravity, and at the pole what will be the gravity, okay. So it's shaped like an ellipsoid, like ellipse it will be, okay. It's not like a circle or a sphere, it will be like ellipse, okay. Like it will be one side it will be long and one side will be short, okay. The radius of the equator is about 21 kilometer larger than the radius of the pole, right. Radius of the equator is about 21 kilometer larger than the pole. Obviously it is greater. When it is greater, what we can understand here, like at the equator gravity is less than the pole, yes, we will come to know that. So the force of a gravity is stronger at the pole, yes, because poles are closer to the earth's center and force of gravity is weaker at the equator, as equator has more like larger height, no, obviously gravity decreases when it compares to radius of the pole, right. So, because the equator is farther from the Earth's center. So, also due to Earth's rotation, there is small outward force, that is centrifugal force will be there, which reduces G a little more. So, we can conclude that G is maximum at pole, G is minimum at equator. If they ask question between the equator and pole, pole is having more gravity than equator. Okay. This is the conclusion from this two topics, that is equator and poles. Understood why we have taken this topic? Yes. So, now non-uniformity of Earth, right. So, Earth's material is non-uniform everywhere, its density changes from place to places, right. No. Okay. So, inside the Earth there are different materials like metal, rock, mineral, water, oil, etc. On the surface we have mountains, ocean, plains. Because of uneven mass distribution, the value of G changes slightly from one place to other places. So, G locally affected, it may be bit higher in some place like dense rock or mountains, and bit lower in other like sea, oil rich regions, etc. Okay. Now, we will go for the Kepler's law. So, Kepler proposed 3 laws. So, the first law which we are going to see is, it is a law of orbit. Okay. So, all planets move around a sun in an elliptical orbit, right. It is an elliptical orbit with sun situated on one focus of the ellipse. So, when we talk about ellipse, no, like one side will be talked as a minor axis, one side will be talked as a major axis. Which is major axis? The larger diameter is major axis, the smaller diameter is minor axis. Okay. So, this is my major axis and this is my minor axis, right. So, here PO, like PO and OA are equal and said as semi major axis, okay, semi major axis. Why semi major? Like half of the major axis called as semi major, half of the minor axis called as semi minor, okay. So, this is Kepler's first law, which is nothing but law of orbit. So, second one, a law of areas, it is Kepler's second law. So, the line join any planet to the sun sweeps equal area in equal interval of time, whether it can be far away or it can be closer also, whatever it is, but the area swept will be equal. Why? Because when I talk about a planet, what planet was initially in this point at time t naught, okay, at time t1 it has been here. So, when I calculate the area, for example, I am getting some value 10, okay. Now, planet was here at time t naught, it has been moved at time t1, okay. So, when I calculate this area, I am getting the same 10 only, okay, same 10, because when I talk about here, like it will cover larger circumference in that ellipse, but here it will cover smaller only. But when I talk about from the point where I can connect the sun right now, like I will get the same answer, okay, I will get the same answer, okay. This is the second law, which is by Kepler, right. The formula is delta A by T will be equals to constant, which is nothing but A by T will be equals to L by 2m. L is nothing but angular momentum and m is nothing but mass of the planet. So, area by time will be always constant, always constant. So, we can say that area is directly proportional to T, directly proportional to T, okay. Now, Kepler's third law, it is a law of periods. So, the square of time period, okay, the square of time period of a revolution of a planet is proportional to cube of semi major axis, cube of semi major in the sense we have considered this major axis as 2a and this as to B. Semi-major means only A will be there. So, square of time period T square will be directly proportional to A cube. This is my Kepler's third law. Time period, no, square of time period directly proportional to Q of semi-major axis. Okay. So, T is time period of planet and A is length of semi-major axis of the ellipse. Fine. You can take a note of this. Can we go for the next one? Okay. So, the next topic is, before going to that, gravitational potential energy. Gravitational potential energy, which is denoted by V. Okay. So, let me give you a simple tabular column to know about what is gravitational potential energy, force from potential energy, near the earth's surface what is the potential, and for the multiple mass what is the potential. Okay. So, this potential energies is nothing but U is equals to minus GMM by R, minus GMM by R, and force from potential energy like F is equals to minus du by dr, F is equals to minus du by dr. So, energy due to attraction between two masses, potential energy. When I talk about force from potential energy, it is attractive force. Okay. So, near the surface, no, we know that potential energy is nothing but mgh, okay. And for the multiple masses, no, what we will do, U will be equals to minus gm1 m2 by r12 minus gm2 m3 by R23, like this we will keep on adding. So, sum of Mi Mj by Rij, like I and J. Okay. So, this is how we will add for the multiple masses. Okay. If you clear about these four formulas, that is more than enough for the potential energy, right. Can you go for the next one? Okay. Now, we will see, so gravitational potential energy, wait a minute, so potential energy associated between two particles of masses m1 and m2, so it is minus g m1 m2 by r, right. So, here is the example. Okay. So we have taken a triangle which like masses has been kept in the vertex of the triangle. So M1, M2, M3. Okay, let me take here. So if we take, this is triangle, this is mass M1, this is mass M2 and this is mass M3. Is this visible, right? Okay. So when I talk about the potential, no, U will be equals to minus G M1 M2 by R12, okay, the distance between them R12 minus G M2 M3 by R23 minus G M3 M1 by R31. Why I am taking like this? M1 will be acting on M2 and M3, M2 will be acting on M1 and M2, M3 will be acting on M1 and M2. So if you see here, 1, 2 is there, 1, 2 is there, 1, 3 should be there, yes. 2, 1 is there, yes. 2, 3 is there, yes. Now 3, 2 is there, yes. 3, 1 is there, yes, it's there. So now minus GM1 M2 by R12 minus GM2 M3 by R23 minus GM3 M1 by R31. Okay. So this is the formula we will take for the triangle. When we talk about a square, no, what will happen for the square? So when I talk about square, vertex M1, second vertex M2, third one M3 and the fourth one is M4. So M1 if we see, it will be acting on 2, 3, 4. Similarly 2 will be 1, 3, 4. 3 will be 2, 1, 4 and 4 will be 1, 2, 3, everything. Like each particle will be acting on the other particles, right. So U will be equals to minus G M1 M2 by, let me take the side of the square as R, okay, side of the square as R. Is this visible now? Fine. So R, so this one will be R12 minus G M2 M3 by R23 minus G M3 M4 by R34, right. So minus G M4 M1 by R41. So we have completed for the vertex like 1, 2, 2, 3, 3, 4, 4, 1, a complete circle has been done. Now if you see, if anything is missing here, 1, 2, yes, it's there. 1, 3 is there? No, it's not there. I need to add 1, 3. So what is this distance? So R, R, like this also R. So what will happen for this one? Hypotenuse, no. So let me take this as A. So A will be equals to under root of 2R square. So which is nothing but root 2R, right? No, root 2R. Right now, let me keep as it is. Okay. If we know the values, it will be easy for substitution. Okay. For simple, I will take this as distance is 1 and 3, R1, 3. So minus G M1 M3 by R13. Now 1, if we talk about 1, 2 is there, 1 3 is there, yes, 1 4 is there, yes, 1 4 is there. Now if we talk about 2, 2 1 is there, 2 3 is there, and 2 4, 2 4 is not there, it's missing. So this also I need to consider. So minus G M2 M4 by R24. Yes, 2 4 completed. Now if we talk about 3, 3 1 is 3 2 is there, 3 4 is there, yes, and 3 1 is there finally, yes, it's there, yes, completed. And fourth one, 4 1, 4 1 is there, 4 3 is there, and 4 2 also is there. So this is the formula for the square. Okay. So this is how we will do for the different objects. Okay. Done? Okay. So gravitational potential, okay, previously we have taken that as U, let me take this as V, okay. V is equals to minus Gm by R is the gravitational potential. How we will get that, like by keeping a some point mass over there, we will experience the potential is there or not. Okay. So, minus Gm by R. So, for this also, for multiple masses we will add like minus Gm by R like that. Okay. Yeah. So, gravitational potential due to ring, potential due to ring. So, formula is V is equals to minus Gm by root over R square plus R square, capital R square by capital R square plus small r square, right. Okay. So, capital R is the radius and m is the mass. Okay. R is the radius, right. Next one, potential due to thin spherical shell. Thin spherical shell. The formula is for the case 1 when we are talking about small r is greater than capital R. So, V is equals to minus Gm by R. When we are talking about capital R is greater than small r, it is minus Gm by capital R. Okay. So, this is the two formulas when we talk about a thin spherical shell for potential, right. So, the next one is potential due to uniform solid sphere. So, uniform solid sphere case 1, small r is greater than the capital R, the formula is V is equals to minus Gm by R. When capital R is greater than small r, no, the formula is, yes, this is the formula, minus Gm by 2 r cube into 3 r square minus r square, right. No, but when I am talking about center, r will be equals to 0. R is 0 means nothing but this one will be neglected out. So, 2 r cube will be there, 3 by 2 will be there, and this r cube and r square will get cancelled, one remaining r will be there. Okay. And r is equals to r, like at the surface. So, what happens here? Let me take it. V is equals to Gm by 2 r cube, this minus, into 3 r square minus r square. This is 0. Minus Gm by 2 r cube into 3 r square. So, 2 r's and this one 2 r will get cancelled off, minus 3 by 2 Gm by r. This is for the case 2, that is r is equals to 0. R is equals to r in the sense, what happens? V is equals to minus Gm by 2 r cube into 3 r square minus r square, right. No. So, what happens here is minus Gm by 2 r cube into 2 r square, 2 r and 2 will get cancelled, and 2 r will get cancelled here. So, formula minus Gm by r, minus Gm by r. Okay. Done? Can we go for the next one? Okay. So, the relation between center and the surface. Okay. So, it is V center will be equals to 3 by 2 times of surface potential. Okay. So, the potential at center is more negative, as we are going deeper it will get negative values. Okay. So, the next one we will see in a tabular column, so that it will be easy to understand. You can take this tabular column. Okay. So, region like ring anywhere on the axis, and outside a shell or a sphere, and inside a shell, and last one is inside a solid sphere. So, 4 cases and object types ring, shell or sphere, shell and solid sphere, and the formulas has been given. Okay. And the nature of this also has been given here. Same for all parts, decreases as 1 by r, and it will be constant and it will be parabolic. Okay. For the graph purpose we have given this. Okay. So, formulas minus Gm by root over r square plus r square, minus Gm by r, and minus Gm by capital R, and this is minus Gm by 2 r cube into 3 r square minus r square. Okay. So, with this we will conclude this today's session of the class. Okay. And in tomorrow's class now we will do problems in gravitation, and we will start with the topic the escape velocity also. Okay. So, thank you guys, we will meet in the next class, bye bye.